solving chemical problems. A lot of chemistry problems end up being unit conversion problems. And so we're going to learn a technique called dimensional analysis. And this uses the dimensions, the measurements, to tell us what to do with the numbers. So the units serve as a guide. So we should always write the units. Okay, the unit is part of the measurement. Units act like variables in an equation. So if you have x times x, that's x squared, right? If you have meter times meter, that's meters squared. Units can also cancel each other out. So a unit equation is a statement showing two things that are equal to each other. So the example given here, 2.54 centimeters equals 1 inch. So we're talking about the same length, we're just measuring it, 1 in centimeters, 1 in inches, and so we're describing the same length in two ways. 2.54 centimeters is the same as 1 inch, right? So from that statement, from that equation, we can make a conversion factor. And in a conversion factor, it's going to be a fraction, and the thing on top is numerically equal to the thing on the bottom. So for this, we can put 2.54 centimeters on top and 1 inch on the bottom. 1 inch equals 2.54 centimeters. So here we have a fraction where the numerator equals the denominator. So what does this fraction equal? 1. We could also write this upside down. We could put 1 inch on top and 2.54 centimeters on the bottom. The numerator is equal to the denominator, so this is equal to 1. If I multiply something by this fraction, which is equal to 1, am I changing the size of it? No, I'm just changing the units. So that's going to look like this. We're given some information, we're given a unit, and they're saying, well, we want to know what that is in this other unit. And so we're going to use a conversion factor in which we have the desired unit on top and the given unit on the bottom. The given unit will cancel out, and we end up with the unit that we want. So let's do an example here. How many centimeters are in 12 inches? So what I'm given is 12 inches. And I'm going to use a conversion factor. I want to put the desired unit on top. The desired unit is centimeters. And I want to put the given unit in the bottom, inches. Because now what's going to happen is inch divided by inch cancels out, goes away. Now I look at this and I say, well, how many centimeters to how many inches? Well, 2.54 centimeters is equivalent to 1 inch. And then I use my calculator. I go 12 times 2.54 divided by 1. And my calculator says 30.48. Don't do that. Centimeters. What should we do about the significant figures? How many sig figs in 12 inches? 2. It's a nice whole number, right? But it's not exact. You can't count inches. You measure them. So this has 2 sig figs. This one is an exact relationship. It's one of the few between English and metric system that are exact. The reason it's exact is they slightly redefined the inch, so that it would be exactly 2.54 centimeters. So this is an exact number, and in a calculation, when we're trying to keep track of sig figs, what we do is we say, oh, we can ignore that one. it cannot limit our answer in terms of sig figs, so we just ignore the sig figs there. So because this is exact, we started with 2, we're going to end with 2. So we're going to keep the 3 and the 0, and we're going to say this is 30. Now it becomes important. Putting the decimal point there says that the 0 is a sig fig. That's still a little sketchy. So if we want to be really, really good, we're going to put this in scientific notation, 3.0 times 10 to the 1 centimeters. Might seem a little awkward, but there's no confusion about whether we mean that 0 to be significant or not. So general strategies and problem solving is something that trips up a lot of students in Chem 1A. We have to learn how to solve problems. Critical thinking and problem solving are a big part of this course. And I am willing to help you. I will work as hard at it as you are willing to work at it. But you got to ask me questions, you got to ask for help. So here's 2 sort of related strategies. Identify the starting point, the given information. Identify the ending point, what you're trying to find. Figure out how to get there, a conceptual plan. So about a year ago, I happened to be at the Stanford Mall, and I was supposed to meet somebody at Starbucks. I hadn't been to the Stanford Mall for years and years and years. So I get there, and I'm like, wow, this is super confusing, right? Outdoor mall and all these buildings. So what do? Well, you go and you find a map, right? And the first thing you have to do on the map is find out, where am I on the map, right? And usually there's like a red circle that says, you are here. Really, really helpful. Okay, I'm here. That's my starting information, where I'm starting. Then I need to figure out, where am I going? Well, I want to go to Starbucks. I need to find Starbucks on the map. And then I have to figure out, how am I going to get from here to there? Oftentimes there's more than one way, right? One might be better to you, another might be better to someone else, but I have to figure out how to get there. And once I've made that path, identified that, then I just have to follow it. Okay? We could also summarize it as sorting, strategizing, solving, and checking. So sorting would be where you find out the starting point and the ending point. The strategize, how am I going to get there? Then the actual calculating, and always a good idea, check your work. Okay, let's look at how to do unit conversions with metric units. So we can make conversion factors very easily between a base unit, that would be like meters or grams or liters, and the same unit that has a prefix in front of it. So here we've got 1 kilometer, and here we have just meter. So this one has a prefix, this one doesn't. So what we need is something from that list of memorization stuff. Kilo stands for 10 to the what? 10 to the 3. So 1 kilometer is equal to 1. Now instead of the K, I'm going to write what it means. It's 1 10 to the 3rd meter. That looks a little awkward, so I'm going to put a times sign in there. 1 times 10 to the 3rd meters. A kilometer is 1,000 meters. A kilometer is 10 to the 3rd meters. So I am going to always do metric conversions in the same way. It's not the only way, but it's consistent. You follow the pattern, it always works. Pretty good odds, if you ask me. Yeah?
Just a quick question. Are we just doing worksheet 1B in lab, or are we turning it in lab as well?
We're just doing it. We're just working on it. It's due next week.
Thank you.
Mm-hmm. So the way I'm teaching you, the prefix is on one side, and the multiplier, the 10 to the something, is on the other side. Always. Yeah.
When we do worksheets, do you want us to do, write out our answer in scientific notation?
That's a good question. So when should I write the answer in scientific notation? Well, if it requests the answer in scientific notation, you better. Otherwise, kind of my rule of thumb is if there's more than 3 zeros at the beginning, if there's more than 3 zeros at the end, put it in scientific notation. I hate having to get my finger out to count zeros, right? It makes me feel like a first grader or something. So in those situations, scientific notation is just easier to look at. It's never wrong to put it in scientific notation. Okay, so that's if you have one prefix. What if both of the units have prefixes? So like changing centimeters to nanometers. Both of these have a prefix. 2 prefixes, do 2 steps. Go from centimeters to the unit without a prefix, meters, and then go from meters to nanometers. There are other ways to do it. If I was doing centimeters to millimeters, I happen to remember that there's 10 millimeters in a centimeter. But centimeters to nanometers, I would have a hard time just coming up with a relationship. It's faster for me to do it in 2 steps. So I highly encourage you to do that. We'll do one example here and then we'll take a little break. Convert 288 centimeters to yards. So the first thing is, what are we starting with? Where are we? Starting with centimeters. The next question is, where are we going? Going to yards. And the third question, how do we get there?
So I'm assuming you would convert it to meters and meters to yards?
You could do centimeters to meters to yards. So in order to do that, we need to know how to convert centimeters to meters. Well, we know what centi means, so we can do that. And then we need to be able to convert meters to yards. I don't know what that conversion factor is.
I would change centimeter to the feet and feet to yard.
Yeah, so this is good if you have available the relationship between meters and yards.
Oh, yard is the American one, right?
Right.
Okay, never mind.
So I don't know that one. So I do know how to do centimeters to inches. And so then how do I get from inches to yards? 36 inches in a yard. Okay, so I can go directly. Now somebody else may have forgotten that and they're like, well, I know there's 12 inches in a foot and there's 3 feet in a yard, and it didn't occur to them to multiply. That's fine. You could do it in 3 steps instead of 2. The thing is, each of those arrows, you have to know the relationship between those units. So just like getting from where you are on the map to Starbucks at the Stanford Mall, there's more than one way you can get there. In most of these problems, there's more than one way that you can get there. And as long as you're getting there, it's fine. You might do a couple laps around the mall, but if you got there, well, that's fine. Okay, so we got the path. Centimeters to inches to yards. I'm just going to cross that off because we realized we couldn't do that. Okay, that's the hard part right there. Once you've got that, everything else is just going to be following a pattern. So what we're going to do is we're going to take our starting point, bring that number back, 288 centimeters. For every arrow in my path, I have a fraction. There's 2 arrows, so this one's going to have 2 fractions. Centimeters to inches to yards. Those are the units in the numerator. Centimeters to inches to yards. I'm just copying it down in the equation. I have centimeters. I want those to go away. So in this next term, I'm going to divide by centimeters. Because centimeters divided by centimeters cancels out. And here, I'm going to divide by inches so that the inches cancel out. You do the units first. Once you've got the units in, they tell you where to put the numbers. So we know that centimeters and inches involves the number 2.54. 1 inch is 2.54 centimeters. So 1 inch is equal to 2.54 centimeters. You have to keep the number with its unit. You can't switch them around. Inches and yards. 1 yard, 36 inches. I don't have to think about, should I multiply, should I divide? Just put the numbers where they match up with the units. And you should always write it out like this, because then if you get the wrong answer, you can go back and look at it and find out where the problem was instead of just starting over. 288. So how do you do this? Multiply by the top of the fraction, divide by the bottom, and just work your way across. Times the top, divide by the bottom. Of course, if you multiply by 1 or you skip that, it's going to be fine. So do what makes the most sense to you. So 288 times 1 divided by 2.54 times 1 divided by 36 equals. It's giving me a whole mess. How do I decide how many digits to write down? Sig figs. How many sig figs in 288 centimeters? 3. What about this guy? It's exact. That's an exact one. How about this one? Also exact. So I started with 3, I end with 3. So 3.14. There's 3 sig figs. I'm going to write down 2 more digits, 96. The unit is yards. And then I look at this first digit I'm getting rid of, and that tells me I'm going to round this up to 3.15 yards. Okay? Yeah. That's an excellent question. Wouldn't it be 2 because of the 36? It would, except that this is a defined relationship. 1 yard is defined as 36 inches. And so there isn't any uncertainty in the 36. It's an exact number. Okay? There's lots of little pitfalls that can trip you up. So it would be great if everybody completely understood this, and did it right every time. Is that absolutely necessary? Is it going to happen? No, it isn't. So how about if we get close? So I'm going to give you a couple of, maybe you could call them hacks for getting these right. Oftentimes in these problems, the number of sig figs you start with is the number that you end up with. And if the problem's set up well, that's how it should be, because you don't want your conversion factors to be limiting your precision. Because even the ones that are not precise are generally known more precisely than what they put in the table. Usually in the table they'll put like 4, maybe 5 digits, because most people don't need more than that. Another way to do it is oftentimes it'll be 3 or 4 sig figs, and so you can just kind of guess. There will be questions specifically about significant figures on the first exam. After that, I want you to always try to get the right number of sig figs, but as long as you're close, I'm not gonna fuss at you about it.